Okay, this lesson's going to review more adding and subtracting, which is a little more difficult because remember with simplifying and multiplying and dividing, we said you just multiply straight across. But remember when you guys add fractions, so you guys have done this a lot in like your trig graphs, you'll be trying to add like pi over 2 plus maybe pi over 3. And we talked about the fact that you need a common denominator. So you guys look at these and you decide 6 is the thing that the smallest thing they could both multiply to make. In other words, the least common denominator. And to make 6, 2 would be multiplied by 3, so that would give us 6. Pi would be multiplied by 3, which would give us 3 pi. 3 would be multiplied by 2 to give us 6, so we have to multiply 2 by pi as well and get 2 pi. Then we'd keep the 6 as the denominator, and we would get 5 pi as our numerator. That process is going to stay the same here. It's just that your factors, instead of being numbers like 2 and 3, are going to be a little bit more complicated, okay? So one of the big things here is going to be to identify what really is the least common denominator. Okay, and we're going to do that by looking at each of the denominators individually and then deciding what they have in common. So if I look at the first denominator, and you might not need all this work, but like for those who do, here it is. It says 5ab cubed. So think about what that really is. It's a factor of 5, a factor of a, and 3 factors of b. You're not taking anything out of the denominator, so you need all of those things to be included in your least common denominator. Now when I look at the second denominator, 3a squared b squared, that's a factor of 3, 2 factors of a, and 2 factors of b. Okay? I already have enough factors of b because the one previous had 3 factors of b. The fact I've already counted 3 is plenty to cover these two right here. Okay? However, when I wrote my a's for this first denominator, I only included 1 factor of a, and you see that this denominator has 2. So I'm actually going to go ahead and make that a squared. And then numerically, it has a factor of 3. 5 doesn't have that, so I need to multiply in another 3. Okay? So overall, my least common denominator for this problem becomes 15a squared b cubed. Now I want to identify what do I multiply these things by to get that. Okay, so what do I have to multiply 5ab cubed by to become 15a squared b cubed? I need to multiply by 3 and another factor of a. So that's what's going to multiply into this fraction, and because I choose to multiply it in the denominator, I also have to multiply it into the numerator here. Looking at the second fraction, for 3a squared b squared to become 15a squared b cubed, I need to multiply by a factor of 5 and a factor of b. And again, if I choose to do that in the denominator, I also need to multiply in the numerator. Okay? I'm going to rewrite what each of these fractions are going to look like. So 3a times 2x is 6 times a times x, and my denominator is 15a squared b cubed. 4y times 5b is 20 times b times y, and a denominator of 15a squared b cubed. We're going to keep that single denominator now because they're the same, just like here, because they were both 6, we just kept 6. And remember, where did 5 pi come from? 5 pi was really made up of 3 pi plus 2 pi. We want to do the same thing here, so we want to add. So this is what's making up our numerator now that we have a common denominator, 6ax plus 20by. Okay. Once you've finished adding the problem together, you still have to simplify like we did in the previous video. So you need to look at this and ask yourself, is this my final answer or not? And the answer to that is determined by if there's any common factors. So really you'd want to look at this and ask yourself if there's a greatest common factor there. So this contains y, but this doesn't. This has x, but this doesn't. So none of the variables are part of the common factor. However, 6 and 20 are both divisible by 2. So I'm going to take out a 2. And then I'm left with this in my numerator, what those terms look like with a factor of 2 removed, and then the same denominator. However, this factor of 2 doesn't cancel with any factors in 15. So my answer actually was okay. So I could have left it like this, or I could leave it like this. However, it is important that I check for that simplification. If I don't check, you may often leave something as your answer that's much more complicated than it needs to be. Okay. All right, we're going to look at part B. And we're going to look at it the same way. The denominators are a little more complicated. So first, I'm going to rewrite them with their denominators in factored form, because remember, your least common denominator is made up of factors. Looking at it like this doesn't really help me if I can break it down into more factors. And again, if you're struggling with factoring, you should pause the video, see if you can factor it on your own and if you get the same things that we do. So I have x squared plus 5x plus 6. That ends up factoring as x plus 2 times x plus 3. And then I have x squared plus 4x plus 4. And that ends up factoring as 2 factors of x plus 2. So again, remember that we're looking to make a common denominator. If you feel stuck here, remember to just start with each one individually, okay? Your first denominator was x squared plus 5x plus 6, which was made up of a factor of x plus 2 times a factor of x plus 3. Start with that. Just like over here, okay, your common denominator is going to include all of those factors. So you now know you need a factor of x plus 2 and a factor of x plus 3, both factors that make up that first denominator. Then take a look at your second denominator, x squared plus 4x plus 4. When we broke that down, we got an x plus 2 times another x plus 2. Our greatest common factor already contains one factor of x plus 2, but it doesn't contain a second one. So we want to put in another factor of x plus 2. So this is going to be the common denominator that we want to make for these two fractions. We want the denominators to have these three factors, 2 factors of x plus 2 and a factor of x plus 3. So now look at your denominators and see what's missing and what you'd want to multiply in. So when we look at the first fraction, I see the denominator, which again we wrote over here, and we wrote that that meant it had these 2 factors. So what it's missing from our least common denominator is this second factor of x plus 2. So that means we want to multiply in another factor of x plus 2 into the denominator. It is okay for us to do that as long as we keep the fraction equivalent by also multiplying that same factor into the numerator. For the second fraction, our denominator contains 2 factors of x plus 2, but our LCD has those 2 factors of x plus 2 and a factor of x plus 3. So here the factor that we're missing is a factor of x plus 3. Okay, so again, I multiplied it into the denominator, which is only okay if to keep it equivalent, I multiply it into the numerator. So now we see that our fractions have the same denominator. So what that's going to allow me to do is write this as one fraction where I know the denominator is this common thing that I've come up with. But the numerator is going to be a bunch of work. So let me say that again. You know your denominator. You're just going to let it sit there while you finish the arithmetic in the numerator. Your numerator contains this minus this, okay? So I have an x times an x plus 2 minus 2 times x plus 3. Now, many people right here are tempted to try and cancel out factors like this. This is a factor of the denominator x plus 2, but this x plus 2 in the numerator is not a factor of the numerator. Because remember, factors only multiply other things. But this x plus 2 is multiplying something and then subtracting. You still haven't done the actual subtraction yet in the problem, and you shouldn't simplify anything until you're done with that subtraction. So to do the subtraction, I am focusing really on what's happening here in the numerator. Okay, so in my numerator, x is being distributed here, so that would be x squared plus 2x. This minus is also going to distribute with this 2 to each of these terms, so minus 2x and minus 6. And then I still have the same denominator. I'm going to keep writing my denominator. Some of you think it's a great shortcut not to, but then you often forget that the problem actually has a denominator. So then notice here that the plus 2x and the minus 2x cancel out or add up to 0x, so I'm left with x squared minus 6 over x plus 2 times x plus 2 times x plus 3. And again, just like the last problem, I want to check to see, does anything in this numerator factor and might cancel with the stuff in the denominator. However, x squared minus 6 does not cancel because 6 is not a perfect square. If it was x squared minus 4, I'd have something I could factor, or x squared minus 9. In this case, I'm stuck, which means nothing's going to cancel, because remember, our brain is thinking about this entire package as the factor, and you don't have another one just like that in the denominator. So this is the answer to our subtraction problem.